Hello everyone, let's look at another integral problem here. We have this typical user problem again. By this first glance, we don't feel like it's a user problem, but actually there is a hint here. There is an inner function that's square root of x, and there is the outer function secant square of x. And actually the second power is also an outer function of the secant, but depends on the situation. We may treat the secant square as a whole function, or just treat the secant as an inner function of the square function, and then the square root of x function is the inner function of the secant function. Okay, so maybe you don't know what I'm talking about. Actually, let's just get started. Okay, so first we are going to change the look of the square root of x into x to the 1/2. This may not be a necessary step, but it's a good idea to do it because you don't want to worry about changing the form as you are doing the calculation. And then you may say, why do we need to do this? It's really because we can do something like taking the derivatives or doing other stuff whenever we are making a use up. So it would be a good idea to just do this. Okay, so this can be an optional step, but it can also be a necessary step depending on how well that you can handle the expression involving the square root. Okay, so yeah, so what do we have right here? We are going to, so just change that. Okay, so this is maybe our 0 step, not the first step. Okay, so what is the first step? The first step is to start making the use up and see what's going on. How do we make the use up? It's actually quite simple here. We are going to just let u be, let's do it on the side, right? So let u be what? X to that 1/2. Okay, so let's do that here. Okay, now what happens when you take the derivative of the u with respect to x? Then we are going to get the du. I'm going to put the dx on the right hand side of the equation. So let's look at this. Using the power rule, we are going to get a 1/2 in the front of dx, and the new power will become -1/2, and then there was a dx right here. Okay, so if you just look at this expression here, that's x to the -1/2, but we don't really have a x to the -1/2 here. So how do we handle this situation? But it turns out that if you just look at this bottom denominator here, x to the 1/2, and then there's this x to the -1/2. Think about this. That negative exponent right here can actually, it tells you that you can actually move this x to the bottom of the fraction. And so this form essentially is actually just what? 1/. Okay, so the 2x to the 1/2 and then the dx. And so let's look at what's going on here. What's really happening is that we do have the x to the 1/2 at the bottom. We do have the dx. And so we do have that x to the 1/2 at the bottom of the fraction, and then we do have the dx here. So what we don't have is actually just this 1/2 here, or the 2 at the bottom with the fraction. So what do we do here? We can either manipulate our integral, or we can simply just manipulate this equation right here. Now, it doesn't look like an equation unless I just copy down the du here so that we have a left side and the right side. Okay, so all we need to do is to multiply both sides by 2's to get rid of this 2 right here. And so we're going to get the 2. Okay, so the 2 is right there. And then we have the du, and then we have 1/x to the 1/2, and then dx. Okay, so all this stuff right here is just this x to the 1/2 and then the dx. So that dx and the x to the 1/2 at the bottom can all be replaced by 2 times du. So let's do that. Go back to the original problem. And then we continue with this calculation. So the integral is right there. And then there was the 2, right? So we should really just put the 2 right there. So 2 is over there. And then now what happens? We'll put the du at the end of the integral. So we are going to put down the secant square right now. So secant square, what goes inside this secant square function? It's actually the x to the 1/2, which is our u, right? So we have the u. And then, of course, there was the du. Okay, so now we get our new integral. which involves u only. And yeah, so there was an extra constant term multiplied to the secant square, but we can move it outside the integral, so don't need to worry about it too much. So it becomes 2 times secant square u du. Okay, so what's next? Now, just recognize that secant square, the antiderivative of secant square, is actually just tangent, right? So if you're finding the antiderivative of secant square, so we're just going to get tangent. It's really, if you don't remember, then we can recall something right here. So let's just recall. Recall that the derivative of tangent with respect to u, of tangent u, is going to be secant square u. Is that okay? So now because of that, then the antiderivative would just be tangent. And so now we can actually just come up with the answer. So we get 2, and then we have the tangent with the tangent u right there. And then of course we have the plus c. That's not finished yet. We just need to do one more cosmetic change for this problem here. The u is actually x to the 1/2. So we plug it back in here, and then we have our final answer. So let's do that. We have our final answer as 2, and then the tangent of what? X to the 1/2, and it turns out that x to the 1/2 is actually our square root of x, right? So let's just put it back in. And then plus c. That's our final answer. Okay, so for this problem here, yeah, so at the beginning, it doesn't even seem like a typical user problem because you have something at the bottom, but it turns out that you can actually move it to the top so that it really just looks like a product. And when it looks like a product, then you can make your use up. So when you get to this step right here, either you can manipulate this equation here to get whatever that you have to match with the integral, or you can manipulate the integral. So at this step, we could have just multiplied 2 here and at the bottom, and then we also multiply 2 at the top to just match whatever that we have here, and then we place the du. So either way, you're going to get that extra 2. So it's up to you. It's not really different from each other. It's just manipulation. Okay, so that's it for this problem. And if you like my videos, please subscribe to my channel and give me some support, and I will appreciate it. And I will continue to make more videos on calculus and other topics in mathematics. Thank you for watching. See you next time.